All right, we're about to dive into a question that sounds like it's straight out of science fiction, but it's actually rooted in a fascinating and very real new scientific theory.
I mean, really think about this for a second. Can an entire forest sense, react to, and maybe even remember an event as cosmic and fleeting as a solar eclipse? It sounds pretty wild, I know, but some really strange signals coming from deep in the woods suggest something incredible might be going on.
So here's how we're going to get to the bottom of this. We'll start with the mystery itself. Then we'll piece together four crucial scientific clues. We'll see how they all snap together into this one really elegant theory, and then how scientists are planning to test it. And finally, we'll talk about what it all means if we can really start listening to the trees. Okay, so our story really kicks off with something genuinely weird that has scientists completely scratching their heads.
So get this. Researchers have been planting these little electrodes in forests, and they've picked up on this bizarre pattern. It turns out that old, massive conifer trees don't just react to an eclipse while it's happening. No, they seem to see it coming. Hours before the sky even starts to dim, their internal electrical signals all start to synchronize right across the entire forest. It's like they're all getting on the same wavelength, predicting the event. And honestly, with the biology we know today, we just can't explain it.
So how on earth could that even be possible? Well, the answer might not be some single brand new discovery. It might be about connecting the dots between four different areas of science that we actually already know about. So let's play detective for a minute and look at the clues. All right, clue number one. It's the simple fact that trees, just like us, just like pretty much all living things, are electric. They have these internal electrical currents, and they're a fundamental part of how they live. And during an eclipse, these currents do something, well, something extraordinary. And we're not talking about some random electrical buzz here. What scientists have recorded is this big, coordinated, forest-wide electrical event that is specifically linked to eclipses. And the oldest, biggest trees, they seem to be the ones leading the charge. Now for our second clue, we're heading into the wild world of quantum biology. It's a special kind of protein with a very cool name and an even cooler superpower. It's called cryptochrome. Okay, this part is absolutely key. Cryptochromes are, first and foremost, light sensors. That makes total sense for a plant, right? But here's the kicker. They're also sensitive to magnetic fields. And during a solar eclipse, it's not just the light that changes. There are also these tiny little fluctuations in the Earth's magnetic field. So these proteins, they could potentially be sensing both signals at the exact same time. Clue number three. For this one, we've got to go underground to this vast, hidden network that basically connects the entire forest. You've probably heard this called the Wood Wide Web, or the forest internet, and that's pretty much exactly what it is. It's this massive, sprawling network of fungal threads that physically link the roots of different trees. It lets them share water, share nutrients, and, even pass electrical and chemical signals back and forth. It is the forest's communication grid. And for our last clue, and this one's a little surprising, we have to look at the one thing that really sets an old tree apart from a young one: its skin. I mean, just think about it. An ancient tree has spent a century, maybe more, collecting this complex layer of dust and pollen and a whole community of microbes all over its bark. This isn't just grime. It's a living, breathing, light-filtering layer. And this unique coating, built up over all those decades, it totally changes how the tree's surface experiences light, especially the very specific shifts in UV light that happen during an eclipse. Okay, so let's recap. We have tree electricity, we have a dual sensing protein, an underground internet, and a special scan that only old trees have. Now, let's see how this incredible new theory called the temporal transduction hub, or TTH for short, connects them all. So here's how it all supposedly works, step by step. First, the input. As the eclipse starts, that dusty old bark acts like a filter for the weird UV light, while at the same time, its cryptochromes sense both that light change and the dip in the magnetic field. Next, transduction. This unique double trigger gets converted into a very specific electrical signal, like an eclipse signature, pulsing at around 2 Hz. Then, broadcast. This signature travels down the tree and gets pumped out into that underground fungal internet. And finally, imprinting. The younger trees nearby, who don't have the dusty bark to sense the event themselves, they receive the signal and it triggers real changes in their biology, creating what you might call a time-linked mark, basically a memory of the eclipse.
Now, it's super important to point out that the scientists behind this are being really upfront. This is not a proven fact. Not yet. They call it a unifying hypothesis, not an established mechanism. And what's so great about it is that it's a designed to falsify framework. It's literally built to be tested and even proven wrong. And that right there is the heart of great science.
So, you've got this wild, incredible idea. How in the world do you actually go about testing it? Let's take a look at how this big idea is getting turned into a real, concrete research plan.
The plan is basically a two-pronged attack. On one hand, you have the natural experiment. Researchers are already gearing up to monitor forests right in the path of the 2026 total solar eclipse. But they're not just going to wait around. They're also building what they call an artificial eclipse rig. It's a setup that can perfectly recreate the exact light and magnetic conditions of an eclipse, which lets them test every single piece of the theory in a super controlled environment. And here's the really clever part. The theory makes these very specific, testable predictions. They're basically a list of pass-fail tests. For example, if the theory is right, only big old trees should be able to send the signal. If you gently wash the dust off their bark, the signal should get weaker. And if you cut off that underground fungal network, the young trees should never get the message.
Okay, so let's just step back for a second and imagine these tests work out. Let's say this whole thing holds up. What would it actually mean? Why does this matter? The plan to figure this out is really methodical, broken down into 3 phases. Phase 1 is the big one, the must-pass gate. Can they even create that specific electrical signal in a lab? If they can, they move to phase 2, proving it can travel through the fungal network. And if that works, then phase 3 is all about showing it has a real, lasting impact on the young trees. It's a serious plan for a seriously extraordinary claim. And this is maybe one of the coolest parts. This isn't just for scientists in some fancy lab. The team is actually designing a low-cost kit that will let citizen scientists, people like you and me, hook up sensors to trees in our own neighborhoods and help gather a massive amount of data during the next eclipse. Look, if this turns out to be true, if forests can really sense and record cosmic events, it would fundamentally change how we see the natural world. It just opens up a whole universe of new questions. I mean, if trees are having this conversation about the sun and the moon, what else are they talking about? It just makes you wonder, what other secret conversations are happening, completely unnoticed, right under our feet?